And good morning. This is going to be a concept map for the free response question 2008, question number 2. And again, the key here is it's a concept map. So these are not the final answers. This is not the final answer that you would want on the AP exam. It's just going to kind of walk through the big idea and the concepts and how to approach each question. It's not going to actually answer the question for you. So let's go ahead and look at the question. So reading through this question, as I'm reading through it, the first thing that I noticed, so number 2, it says concert tickets went on sale at noon, time 0, and were sold out within 9 hours, so there's the end of our time interval. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable, so you can take the derivative of it twice. Function, call it L, from 0 to 9. Values of the function L of t at various times are shown in the table above. So the first thing I always pick up on when I'm reading these free response questions is identifying whether they're giving you a rate function or an amount function. So this one is an amount function. So it will tell you the amount of people at any particular time. If it was a rate function, if it was telling you the rate of change of something, then the area under the curve would represent something. In this case, it is not a rate function. It's not a derivative of something. It's just telling you the amount of people at any one particular point in time. So part A says use the data in the table to estimate the rate. So we're going to want the rate. So when I read that, I think slope. So this is going to be a slope question. So once the rate of change at which the number of people waiting in line are changing at the instant in time of 5.5. So they want to know what the slope is, the rate of change at 5.5. So somewhere between 4 and 7. Since we don't have an algebraic equation for L of t, we can't just go take the first derivative and find L prime. So we're just going to have to use the chart to come up with a approximate slope. So remember, the idea of slope is change in y over change in x. So we're basically looking for delta y over delta x. Or basically y2 minus y1 over x2 minus x1. And where you're going to get your x and y values, that's where you're going to be looking at the chart. So these are your outputs, your y values. These are your inputs, your x values. So we're going to want to do the change in the y values, 150 minus the 126, compared to the change in the x values, which is 7 over 4. So looking at a potential setup for that, it should be 150 minus 126 over 7 minus 4. So we can put in the numbers. 150 minus 126 over the change in the x's, 7 minus 4. And they did want the units on this, so indicate the units of measure. So if you're doing the change in people compared to the change in hours, change in y compared to change in x, then that's going to be people per hour would be your units that they are looking for. And let's clear this and go look at part B. So part B, it says use a trapezoidal sum. So we're going to be using trapezoids to find the area. So use a trapezoidal sum to estimate the rate at, that's part A, sorry. Part B, use a trapezoidal sum with 3 subintervals to estimate the average number of people. So when I read this, the first thing I think of is average value. So we're going to be talking about the average value. So that's the key idea here. And the average value, or the average output of a function, is the total area from A to B of whatever function you're dealing with. divided by the length of the interval. So that's going to be your average value. And how are we going to find this total area from A to B? They said you're going to use a trapezoidal sum to do that. So you're going to be using your trapezoidal sum to find this part of the average value formula, and then you'll have to, don't forget to divide by the length of the interval B minus A when you're all done. So they want to know the average number of people, the average value, waiting in line during the first 4 hours. So you're going to use trapezoids to find your area in the first 4 hours, and then divide by the length of the interval, which is going to be 4 minus 0. So the B minus A down here is going to be the 4 minus 0. So use a trapezoidal sum to find this, and then divide by the length of the interval. And part C, it says for time between 0 and 9, so time interval 0 to 9, what is the fewest number of times in which the first derivative, L prime, must be equal to 0? So the big idea, or the first thing I think of, is if L prime is going to be equal to 0, then the function must be changing direction. So if you remember when we studied relative extrema, mins and maxes, if you have a function changing direction, then your first derivative is going to be 0 every time it changes direction, or undefined if it has a sharp turn, but they did say it was differentiable on the entire interval, so they're not going to be sharp turns in this case. So it is going to be changing direction, and it's going to be not a sharp turn, but a peak or a valley, where the first derivative is 0. So you're going to be looking basically at the behavior of the function and trying to determine how many times it changes direction, and by that we mean how many times does it switch from increasing to decreasing, or vice versa. So you're going to be looking at kind of the trend in the table. So notice at time 0 it was at 120 for an output, and then at time 1 it was at 156. So from 0 to 1 it was increasing. So it was increasing. And then from 1 to 3 it ended up at 176. So it had to go from 120 to 156 to 176, so it's still increasing. But then notice from 3 to 4, it went back down to 126. So somewhere between 3 and 4, it had to start going back down again to get back to 126. So you're going to be examining the behavior of the function and determine how many times it changes direction, and that's going to be how many times L prime must be equal to 0. And let's go ahead and look at part D. So part D says the rate at which tickets were sold from 0 to 9 is modeled by this function. So this function they're giving us, R of t, is a rate function. And every time you know you have a rate function, they're probably going to possibly ask you about something about the area under the curve. Because if it's an amount function like what they gave us in the table, the area under the curve doesn't usually typically represent anything of significance. But if it is a rate function, a first derivative of something, if it's telling you how quickly something is changing, a rate function, the area under the curve is going to represent the total amount. So if you have some sort of rate function, R of t, and if you're, whatever it's doing, if you're looking at the area under the curve from A to B, then that is going to be telling you the amount of whatever it is that you're talking about that was accumulated from A to B. If it's above the x-axis, it's going to be accumulating positive amount. If it's below the axis, it's going to be accumulating negative amount. So the fact that they give me a rate function tells me they're probably going to ask me about the area under the curve. So we have a rate function, and here it is. It's kind of a complicated one, so they're probably going to expect you to do this on the calculator. And then it says based on the model, how many tickets. So how many, that's an amount. So that's the amount they're looking for. How many tickets, the amount of tickets were sold by time 3. So they're going to be looking for the area under the curve from time 0 to time 3. So essentially what you're going to be doing is you're going to set up an integral. See if we can make some room here. You're going to be setting up an integral where you want to integrate the r of t function from 0 to 3. And you're going to want to probably do that on a calculator. They gave this to you. You probably, to force you to go do that on a calculator. You're probably not going to want to take the time on the AP exam to try to work that out by hand. So integrate from 0 to 3 on that rate function will give you the amount of tickets sold. And round it to the nearest whole number. So a lot of times they want to 3 decimal places. In this case, they did say the nearest whole number, so the nearest whole ticket. They're not going to sell a fraction of a ticket. And that is it. That is the walkthrough for question number 2 on the 2008 free response exam. Again, those are not the final answers. That's just a quick walkthrough of how to approach those problems you would want to go through and finish them up.